Hi everyone, welcome back to Coding Hives. Today I am going to show you one of the most mind-blowing things in modern AI development. How JAX becomes super fast when you run it on a TPU. Now listen, if you have ever felt like your Python code is slow or NumPy operations takes too long or you have tried to train a model and your laptop started screaming, this video is going to change the way you think about speed. By the end of this video, you will understand how to check if a TPU is actually working, how JAX feels just like NumPy, how JIT magically makes code hundreds of times faster, how automatically gradients work, and how to train a tiny model in just a few lines of code. I will run all of it live on Google Colab so you can see real results. So get ready. Alright, we are inside Google Colab. Before we run anything, do these two steps. First here, go to runtime. Here you need to change the runtime type. I have already changed it into TPU. This is the hardware accelerator. We need to choose TPU. So I choose this one. This will give us the crazy speed boost. Okay. Just save. So here I am planning to show you 5 cells. I will explain it. So this is the first cell I have already written here. We are checking our engine before driving a car. It tells us two things like which version of JAX we are using and what hardware JAX is running on. Okay. So if the TPU is connected correctly, we can see the result. Now I am trying to run this code. You can see as we reached the limits of this TPU, I cannot use now. But I tried it before. So for the time being, I'm not connecting with the TPU. So you can see here we are getting like this version, JAX version, and the device which we using. I mean which accelerator we are using. Now coming to this cell 2, if you know NumPy even a little bit, you already know half of JAX. So both NumPy and JAX create arrays in almost the same ways as you can see here. So when I am running the cell, you can see I'm getting the output like this, same output. Okay. So you can think like NumPy as a normal bicycle and JAX is same bike but with a huge electric motor attached. You get speed without changing how you ride. Okay. Now we will analyze the next session, that is cell 3, that is related to JIT compilation. So here I have written some function. So here I have a function named slow op. I am calculating some operation and I am calling this slow op function here using jax.jit. Then I am preparing some input to show the difference. Okay. Then I am calling this function here. I mean here. Then second time again I am calling the function here. So here this jax.jit can make our Python code hundreds or thousands of times faster. What happens is the first run is slow because JAX is actually compiling our Python into a super optimized GPU or TPU program using XLA. Okay. And the second run uses compiled version and it will be shockingly fast. I will show the result here. You can see here in the first call it is the time taken is like 0.110 something like that, and the second time is like you can see 0.00040. Okay, so here you can literally see the speed boost. I like sometimes it is 100x faster, sometimes 300x, sometimes even more. Okay, now coming to this cell 4 section, the cell 4 section shows one of JAX superpower, that is automatic differentiation. Okay, this is the same concept used inside neural networks for back propagation, but instead of doing heavy maths, we just use JAX.grid as you can see here. Okay, so we will run the cell. We are getting the output something like this. This is our output 23. Okay. Now coming to cell 5, this is like a tiny linear regression. So here we have some arrays. You can see here tiny data set, and we initialized this parameters w and b. Then we have the function for model and loss. Then we are calling the function. Then we are training using a loop. This is a tiny training loop. The smallest possible machine learning model. We are training a model to learn the equation y is equal to 2x. Okay. So we start with the wrong values. I mean, w equal to zero point 0.1 and b equal to 0. And during training, JAX will slowly adjust them. This is the foundation of all neural network. So as you can see, the output is something like this. So here you can see w went from zero point 0.1 to something close to 2, and b went from 0 to something close to 0, which means the model actually learned the rule y equal to x completely by itself. So this is how ML training works even in giant models. Okay. So we connected to real TPU, but here as the time as the limit is over, I am not able to connect show you that. We used the JAX just like NumPy. Then we saw JIT make code insanely fast. Then we computed derivatives automatically, and we trained a tiny ML model from scratch. Okay. So that's it for today's video. Thank you for watching. Have a nice day.